Hello, algebra class. We're going to go over to chapter 5 extra credit right now. And there we go. Get that cleared up. All right, let's take a look at the first one. Which set of ordered pairs satisfies a linear function? Okay, so you want to be clear that there's two things they're asking you, linear and function. So function, again, is when each one of these can only be paired up with one other value. So that is definitely a function. That's a function. That's a function. Well, that's not even a function, okay? Because this 6 is matched up with all these numbers. So that's just not even a function. But now we need to look to check if it's linear. That means it makes a line. So we need to check the increments and make sure that the x goes up by the same amount and the y. So let's look at our x. This goes up -6 to -3. That goes up 3, 3, 3, 3. Okay, so that's consistent. Let's look here. This goes down 3, down 3, up 3, up 3. No. Okay, let's check B. That one's out. Down 1, down 1. I'm sorry, wrong. Up 1. Up 1, up 1, up 1. Good. Down 3, down 1. Hopefully it's this one. It's our only option left. Up 1, up 1, up 1, up 1. Good. Down 3, down 3, down 3, down 3. Yay! So that's how you would check that. Next, vacation home in Orlando, Florida rents for $105 a day. The function here gives the cost, so this right here is going to represent your cost of renting the home for X days. So our X represents the number of days. What is the domain? Again, be very careful that you read your questions. Have that little highlighter out so that these things jump out at you and you don't accidentally do the range. So domain is always the X value. So let's look in here again. What was the X? The X meant the number of days. So what is the domain for the number of days for this function? Well, how many days could they go to Florida? It's not going to be this because I can't rent out for 1.5 days. And that includes all decimals, 1.2, all decimals here. Let's look at this one. Could I rent for 0 days? Sure. 1, 2, 3, yep, that looks pretty good. I'm just going to look at the other ones to make sure I didn't make a mistake somewhere in my thought. Could I rent for, yes, I could rent for these days, but this is not including. Remember, this has to include all my possible days, and it's missing a whole bunch of them, isn't it? And all real numbers would also not work because all real numbers, you can't rent for pi days, can you? Or square root of 5 days. And those are all real numbers. All right. An apartment, well, actually, let me backtrack for 1 second on this one. What if I were to ask you for the range? Can you make sure you look at the question again to see it clearly? That's your y values. So what would that be if I had asked you that instead of the domain? Well, remember the y values, that's your f of x right here. So you're trying to figure out what would that be? Well, you would have to figure out what are my possible range values given my domain values. So in other words, if I picked 0 days, how much money would that be? That'd be $0. And what if I picked 1 day? What would that be? $105. And if I picked 2 days, $210, and so on. So that's going to be my range. So actually what they gave you here was your range values. So X is your domain and this is your range. And you actually have to substitute those values in to see what it would be. What are they? Okay. An apartment in Valparaiso, I'm not sure how you say that, India, rents for $600 per month with $1,000 deposit. So the deposit means you have to give them this money up front. So you give them $1,000 and then you're also going to pay them this. So when you move in, you literally will give them the $1,600. The rent is month to month. Okay, so you can't rent 1.5 months. But you must stay at least 1 month. So not, obviously, you can't stay for half of a month. You got to stay for 1 month, 2 months, and so on. The function, which they give you right here, they figured it out for you. So here's the $1,000 deposit, and here's the 600 times however many days, or not days, months. And they say that right here too. X is the number of months. And then Y, or f of x, is your cost that it's going to be. So it says graph this function. So if you can only stay in the month increments, this is going to be a discrete function, isn't it? You have to stay by the whole months. So let's do a little XY chart and see what we get. I can't pick 0 because it just said here you have to stay at least 1 month. So I'm going to pick 1. And if I put 1 in here, I get 600 and 1,600. So that's what I had just said to you. Your first month, you're giving them that. Second month, or if I, oh, actually, I'm sorry, it's not how much you're giving them each month. It's if you decide I'm going to rent for 2 months. If you're going to rent for 2 months, it's going to be 1,200 plus 1,000. So 2,200. And if you say, nope, I need to rent for 3 months, it's going to be 1,800 plus 1,000. And so on. So you, I guess, are telling them up front, this is how many months I'm going to stay, and then that. Because you're not going to pay them that 1,000 every month. You're just saying, if I stay 3 months, that's how much I'm going to pay. If I stay 4, etc. So let's graph it. Your x values are your number of months. So this is my months. So my time. Now it's going to do 1, 2, 3, 4, and 5. And we're going to make this my cost. And let's see, what values do we have? We want to start at 0 so it's accurate. So I'm going to go by 500s, or I could even do 1,000. I think I'll do 500. Either would work. Okay, let's graph them. So nothing at 0, because we're not staying 0. 1 is 1,600, and 2 is 2,200, and 3 is 2,800. And do I connect them? No, because you're not staying partial months. You're only staying whole months, so I just put them there and I'm done. So now when I ask you for the domain, you pretty much almost have it here. And the range is Y. And I kind of have a start right here, don't I? So your domain is going to be 1 month, 2 months, 3 months, and so on. So I got to put those little ellipses in there to imply that it goes forever in that direction. Those are also called what kind of numbers? Remember? Those are your natural numbers or counting numbers. When you start counting, you start with 1. Okay, and the range is your Y. So again, you're going to list these separately. 1,600, 2,200, 2,800, and then you put the ellipses implying that that's going on in that pattern. Okay. Sometimes it'll be continuous. So let me just say, what if, you know what, I'll do that at the end. Let's just keep moving. All right, parking meter gives 30 minutes for each quarter and 6 minutes for each nickel. Then the equation here, so they actually put this together for you, which is nice, but they go on to explain how they got it. So this describes the number of quarters, X. 30 minutes was each quarter. So that's how they got that. And nickels was Y, and nickels were 6 minutes each. So that's why they have the 6 times the number of nickels. And together, it equals 60, because their question is, the equation here describes the number of quarters, X, and the number of nickels, Y, that you need to park if you were doing 60 minutes. So they chose 60. What does the x-intercept represent? Okay, so the x-intercept is when what do we cover up? If you want the x-intercept, you cover up the y, which basically means your y is 0. When you cover it up, you're implying it's 0. So if I'm covering up the y and making it 0, what do you have left? You have 30x equals 60. Get that a little better. There you go. 30x equals 60. Divide both sides by 30. X equals 2. So the x-intercept is 2. So what does that mean? Well, if the y was 0, you were saying you have 0 what? Nickels. That was my nickels. And the y-intercept is 2. And what was the y-intercept? I mean, the x-intercept is 2. And what was the x? X was the quarters. So that was saying that when you have no nickels, you're going to need 2 quarters. So let's see what we have here. You need 2 quarters and no nickels. Oh, well, that's it. Let's just make sure I didn't make a mistake. 10 nickels, no. Nickels for sure are 0. Oh, here's no nickels. 30 quarters, no way. That's a lot more money. That's a lot more. Yep, so A is it. All right. This one, the calculator is okay. This table shows the number of people at a festival at certain times during the day. Okay, so at 1 p.m. there's 12 people, and at 2 p.m. there's 20, at 4 p.m. so on. During which time interval did the number of people increase at the greatest rate? What was the rate of change for that interval? So first thing you have to take note of is, look at, this is 1 hour between here, and there's 2 hours between here, and there's 3 hours between here, and 1 hour between here. So you can't just strictly look at the change in the people. You got to figure out the rate, like how many people per hour. And that's ultimately what you're going to look at. So when it's just a 1 hour shift like here, that's pretty simple. You can just subtract these two. So this changed 8 per hour. 20 minus 12. And this one likewise only changes 1. So that again, you can just subtract this, and this changed 5 per hour. But these other two changed by, there's 2 there. So I'm going to have to subtract this. 34 minus 20 is 14. And then there's 2 hours though. So I got to divide that out by 2. So 14 divided by 2 is 7. So this is 7 per hour for that one. And then again here, now look at that. These were all 1s. So those are fine. This was 2 and this is 3. I like that up there better. So I'm going to have to get whatever I get here and divide by 3. So 40 minus 34 is 6. And then 6 divided by the 3 is 2 per hour. So which one, again, what does it ask you? It says which time interval. So first I have to tell them the interval. I've got to make sure that I'm answering all the questions. We need time interval and we need rate of change. So the time interval that it was the biggest, if you look at these numbers, was definitely here. So the time interval was time, not number of people in a time, was from 1 to 2 p.m. Now it also says what was the rate of change for that. So I go here and that is my rate of change. It was 8 people per hour. All right, now we're going to take a look at the next one and do slope. And you didn't even need your calculator for that. I wonder why I said you could use your calculator. Find the slope of this. Slope again is, oh dear, my son is home, but you said you couldn't hear him last time, so you probably can't hear him this time either. Change in y over change in x. Make sure you don't flip it. So let's find out. They give you a dot right here. It's kind of hard to see on my graph. I think that is 2, 1. And then they give you another dot right here, which is 0, negative 4. So I need to go in there now and make sure that we use the y values and the x values. So here's my y. 1 minus negative 4. Watch those signs. I got to go the same direction now. If I went this direction, I have to go this direction. 2 minus 0. So 5 over 2 is my answer. Where is it? It is right here. Oh, I love that pink. Who else loves that pink? Yes. It's my favorite. And therefore, it's time for a commercial break. I'm now advertising for B2P pens. They are Pilot, and that's a 7mm pen. It ranks up there, but doesn't have quite the, of course it doesn't erase, but as you notice, it does have a much better color than that. I mean, let's face it, that it's much more brilliant and vibrant than that. So although I recommend these for the best erasable pen, which is the Flexion, I do recommend these for the most vibrant. All right, thank you for that commercial break. Let's go on. All right, find the slope of the line that contains this. Oh, well, that's easy, right? That's just another slope like we just did. So we need to do change in y over change in x. So I'm going to put that formula here again. Okay, and I'm going to look over here, and here's my x and my y, my x and my y, my x and my y. So we want to take and subtract my y's first. I'm going to just do the 11 minus 5. Since it's going positive, you can do the 5 minus 11 as long as you go the same way with the 4 minus 7. So 11 minus 5 on top, 7 minus 4 on the bottom, and I get 6 over 3, which is 2. So my slope, which is signified by lowercase m, is 2. Now I need to find the midpoint here, and the midpoint is, remember, an average. Okay, it averages your x's and it averages your y's. And we know averaging is adding up values and dividing by the number of them that there are. So if I'm averaging my x's, I'm adding them together and dividing by 2. So when you see this, we don't have to really memorize this, do we? You just have to remember what it means to average your x's and average your y's. You're trying to find the midpoint. So it makes sense. So let's do that. X's go first because we're trying to get another coordinate here. This is a coordinate I'm trying to find. A midpoint. Find the coordinate. It shouldn't be a number like this, slope. It should be a coordinate. So 2 plus a negative 6 divided by 2 is my x's. And negative 6 plus 2 for my y's. Looks pretty similar to me. 2 plus a negative 6 is negative 4 divided by 2 is a negative 2. Negative 6 plus 2 is negative 4 divided by 2 is a negative 2. So here we go on to this one. M is the midpoint of QR, and M has a coordinate of negative 4, 4, and Q has a coordinate of 6, negative 8. So which represents this other coordinate? So now instead of you finding the middle and averaging, they're saying, okay, I mean, you can graph this if that helps you to visualize it better, but they're giving you this midpoint. And although there's a whole way you can use this to solve it, what I've found is students understand it best when we just do a little vertical thing where you have one point up here, and then you put the midpoint, and then you find the second point down here. So the first point, what is the actual coordinate they give you of one end? Q is one of my ends, and so is R. So they give you Q, and it's 6, negative 8. The midpoint always goes in the middle. Midpoint is M. M is the midpoint, and M has a coordinate of negative 4, 4. And then you're trying to find the point on the other side, right? Because the midpoint's in the middle. So if you just look at the difference between the first two, it will continue in that same direction. So when you go from a positive 6 to a negative 4, what are you doing? You're going down 10. Well, then you keep going down another 10. They subtracted 10 here. You're going to subtract another 10 and get negative 14. Here, from negative 8 to positive 4, what did they do? They added 12. So you're going to add another 12 and get 16. So there's your answer. All right. Find the distance. I need a little bit of a color change. Find the distance. So the distance formula is a subtraction of the x's squared plus the subtraction of the y's squared. So you're finding the difference of the x's and squaring them and the difference of the y's and squaring them. And what have I told you about these? They're always positive because you're squaring them. So you should never be adding a negative in here. When you're done squaring them, you should have a positive plus a positive number. If you get a negative here, something went wrong in your calculations. Okay? So we are going to do subtract your x's. 6 minus a negative 2. Be careful. Excuse me of the signs. 3 minus a negative 3. Now let's do that. So 6 minus a negative 2, that's a plus. So 8 squared, 64. Plus, here we go again. We can change that to a positive. 3 plus 3 is 6. Squared is 36. Now we add them. When we add them, we get square root of 100. It's always in the square root. Now in this case, square root of 100 is lovely because it's 10. My answer is 10 units. I don't know what the distance is. All I know is it's a distance, so we use the term units. But if I had said feet or inches or anything, you would use that. But if this would have come out to 101, unless I said to round it to a certain value, you would just leave that as your answer. Okay, that's the exact answer. As soon as you plug in something that doesn't come out whole, you're approximating. All right. Varies directionally, direct variation. Okay, the value of y varies directly with x. Okay. Now I've taught you that you can set these up as a proportion because here they give you a y, here they give you an x, here they give you another x and want you to find a y. So we can set up a proportion. Negative 2 is my y over my x equals, and I still have to put y over x over here. Find y, so y is on top when x is 50 and x is still on the bottom. And remember, when you solve a proportion, you're just cross multiplying, and in this case cross multiplying and dividing. So it's gonna be 15 times negative 2 divided by 5. But the way you get that is 5y equals negative 30. Divide by 5. And answer is negative 6. B. Okay. Which equation describes the line with a slope of 5 and y-intercept of negative 3? When you look down here, what form are these all in? Slope-intercept. They're all in that form, slope-intercept, y equals mx plus b. So this is pretty straightforward. They gave you the slope of 5, and remember the m is your slope, and they gave you the y-intercept of negative 3, and b is your y-intercept. Not your x, your y. So it's y equals 5, I'm just substituting, plus a negative 3. Okay. Well, we know this is the same as that. So let's see where our answer is. Right there. All right. Write the equation, x minus 3y equals 9 in slope-intercept form. Whenever I ask you, and I just showed you it down here, slope-intercept form, what is it? It's solve for y. When I ask you to put it in slope-intercept form, it means solve for y. It means get y all by itself over there. Okay? So I need the y alone. Okay, I don't move the 3 first. That's closest. That's multiplied. We do opposite of Pem does. So we got to get rid of the x first. So subtract an x, because I look at the before the x, and it's a positive x. So I need to subtract x. Those are gone. Don't forget, though, this negative is attached here. So I have a negative 3y. Don't lose that. And I'm going to write this with the x term first, because that's how the intercept form is written. Last step, I got to get rid of the negative 3. So I'm not going to add 3, because the negative 3 isn't added to this. It's being multiplied. So we're dividing by negative 3. Do every term. That's the simplest way. What's a negative divided by a negative? Positive. And what number is before the x? A 1. So I have a 1/3 x. And it's minus because of the negative down here, 3. Okay, so again, I gave you multiple directions here. So write the equation and graph. I highly recommend highlighting directives, especially when there's more than one, so you don't forget. So I'm going to write this. My line there. And now when you are graphing these, again, you have the slope and the y-intercept. The slope is 1/3. The y-intercept is negative 3, right? Because the equation is assuming it's a plus. So this negative attaches to the 3. So the slope, y-intercept is negative 3. So let's graph that. Which one do you graph first? Yes, you graph the y-intercept first. So I go to my y, and I go down to negative 3 and put it up. Now when I do the slope, it is from this point, not the origin. I start here, and I rise 1 and run 3. So I rise 1 and run 1, 2, 3. And get my little handy dandy straight edge out. And we're all done. Write an equation in point slope form. Oh, point slope, new form that we learned. And again, and some of them have y2, y1, it doesn't really matter. It's just signifying these are different, these are different. This is the slope, and these are a point on the line. Whoopsie, on the screen, there we go. Okay, and these should be in your equation when you write it, just x and y, just like we have up here. We leave an x and a y in there. Likewise, we leave an x and a y in here. Okay, well, oh my goodness, they give us the slope. So they gave us that. And they give us the x and a y. So that is your pointer. And you can say x1, y1 here so you don't get confused. They give you this and this. And again, you leave these in there. So let's do that. So my answer would be y minus y1, 2, equals slope, parenthesis, x, leave it, minus x1, 1. Done. That's it. I recommend labeling them so you accidentally don't put them in. Just do these little extra things so you don't switch things up. Write an equation in point slope form, again, there it is, such that the line goes through these points. Okay, so I have a question for you. They call this point slope for a reason. You need to be able to put in a point and a slope. Do you have a point? Yes, got two of them. And guess what? You get to pick which one you want to use. You can use either, and it'll be correct. Okay. I'm going to pick the positives. Less chance for error, but I pick this too. Slope. Now in here they don't give it to you. Here they gave it to you. But can you get slope with 2 points? Well, I hope so, because you just did over here. All right, so let's do that. Slope is y2 minus y1 over x2 minus x1. So y minus y over x minus x. My answer is 5 over negative 5, which is a negative 1. All right, now I got everything I need. I've got my slope and I've got a point. So let's plug it in. Again, I'm plugging it into this equation. Oh, I have it right up here. You can still see it, that equation. So I leave the y. I put in, I'm going to pick this one first, but I'll show you both. Actually, yeah, that's fine. x1, y1. I'm going to do that one first. So y minus the y1 equals slope times x minus the x1. 3. Done. Or y minus, now I'm going to use this one, x1, y1. Remember the x always comes first in the coordinate. So y minus the y1, 6 equals slope, same slope, times x minus x1. Okay, either of those would be acceptable, and if you change that, that's all the better, but I'll accept either. Okay. Now, identify which are parallel. Okay, well, you're given a whole bunch of equations here, and you got to be able to pull out what in order to figure it out. In order to determine if it's parallel, you need the slope for each of these. Because remember, to be parallel means the slope is equal. Okay, so we're looking, first of all, what are these in? What form are these in? Let's see here. This is in slope-intercept, isn't it? Y equals mx plus b. It's just there's no b, right? It's 0. So what's the slope for this one? 4. All right, this is also in the right form. Y equals mx plus b. B is negative 1/4. Okay, we don't have a winner yet, because in order to have parallel lines, they have to be equal. So right now, actually, these are perpendicular, if we must be honest, right? Because perpendicular takes something and flips it and takes the opposite sign. So these two lines are actually perpendicular. Now, these are a little more difficult because we have to get this solved. So we have to solve it for y. We got to get it into this form. So again, I'm just going to solve it right here. Solving for y. So I'm going to move the x term first. Don't forget the negative sticks. Put the x first. Can't combine them. You write them separate. Divide by negative 3. There we go. What's the slope? We have it in the right form now. Y equals m x plus b. Yay! I mean, I can go ahead and solve this one, but as of right now, I've got these two are parallel. Although it doesn't say it's only 2, so we better go ahead and solve just in case. I'm going to change color here because I need to solve this for y. So the first thing we're going to do is distribute 4y plus 24 equals x minus 3. I got to get the y alone, remember. Subtract 24. Put that with the number over there. And lastly, divide it all by 4. What's before the x? A 1. Slope is 1/4. So it's close, but they're not the same. Sorry. They're not the same. That's negative 1/4. That's positive 1/4. So this is the winner chicken dinner. Okay. Almost done. Just need to have a little commercial break. Today we are showing the LaCroix Curate, I don't know how you say it, Cerise Limon. It is a cherry lime natural essence sparkling water. It comes in, well, let's see here, 0 sweetener. No, wait, back it up. 0 calorie, 0 sweetener, 0 sodium equals innocent. Got a 12-ounce can here we're going to try. Pure refreshment. Highly recommended. That lime is a beautiful taste. All right, back to math. Back to our regularly scheduled program. And I'm on the wrong problem. Write an equation in slope-intercept form for the line that passes through this point and is perpendicular to this point. So what do we have here? We have a point. We don't have anything else. We just have this line that it is perpendicular to. So when they give you another line that it's either perpendicular or parallel to, the only information you want from this is the slope. So the slope of this line, it is in y equals mx plus, y equals mx plus b form. So I know the slope of this line is 3/2. So if this was a parallel to this line, I'd have my slope, right? Because they'd have to be the same. But it's perpendicular. So I can get the slope from this, though. The slope, remember, you take the reciprocal and the opposite sign. So now I've got a point and a slope. Oh, point, slope. Yay! I can put it in my point-slope form and solve. So again, you leave the y. This is my x1, y1. And you put in the y. Slope is negative 2/3 x minus negative 3. All right, add. Y minus 2 equals negative 2/3. Let's multiply because we're, oh, sorry, I'm jumping ahead here. We got to get it into slope-intercept form, which is y equals mx plus b. So that's why now I'm going to take this and solve it for y. If I ever need to go from this one to this one, I'm just solving for y. So I'm going to distribute right now. And negative 2/3, if you notice, times 3, which is over 1, gives you a negative 2. So that's how I get that. I shall add 2 to both sides now. And I get negative 2/3 x. And that actually drops out. So there's my answer. Next, graph f of x equals this, g of x equals this, then describe the transformation. Okay, a couple things to do in here, graph and describe. Okay, so let's graph. So let's do the first one, f of x equals negative 2x plus 4, and put the other one over here. Oops. Next thing I love is these. I hope St. Nicholas brings me lots of whiteout Bic, just like those. There's nothing better, of course, other than the great pens that I have. There we go. It's going to do xy. Remember, this is just like a y. When you see that function, that's just a function notation. So when I pick an x, and these are lines, so I need for sure 2. 3 for good measure, like if it's a test, but you don't have to. Put in 0 for x. Negative 2 times 0 is 0, plus 4. Put a 1 in for x. Negative 2 times 1 is negative 2, plus 4. So I've got 0, 4, and 1, 2. Let's go over here. If I put a 0 in for x, 0 times this is 0, minus 4. And I see that this is 0.5, which is a half, so I'm going to purposely pick. Well, you know what? I'll just do 1 because you guys would probably pick 1. If I pick 1, I have a negative 1/2 minus 4, which would be a negative 4.5. So 0, negative 4, and 1, negative 4.5, which is here. You know, I'm going to do another one because I just so close together. I want to have a better graph. So I'm going to do 2. If I put 2 in here, 2 times a half, it's 1. So I have a negative 1 minus 4, it's a negative 5. That helps a little bit. It's at least right there. Okay. And thank you, whiteout. I had it at 1. It's 2, negative 5. 2. There we go. All right, so let's take a look at that. What the heck is going on? So I got the graphing done, but we have to be able to describe the transformation. So remember, where was my beginning? My beginning was the f of x. And my ending was the g of x. So we're trying to say what happened from f of x to g of x. Well, if they're intersecting, you for sure have a rotation. Okay, if that was a translation, it would have been parallel. It would have just slid. But here it looks like it's slid and rotated. Now, I know it's slid, which is a translation, so I'm going to write that. It's a translation. And the way you can tell is you look at your y-axis. It went down how many spots? It went from a positive 4 down to a negative 4. So translated 8 units which direction? Down. Okay. And it rotated, and to know the point that it rotated around, do you remember how to tell? It's the original y-intercept. That's actually what it rotates around. So what was the original y-intercept? Right here. So rotate around 0, 4. And you can also tell me more if you want. Did it get more steep or less steep? Looks to me like it got less steep. You can tell that as well from the slope. The slope went from 2 to 1/2. I remember the higher the slope, the absolute value of the slope, the more steep it is. And that's it. Okay, so I remember there was something. What was it that I was going to go back to? I remember. Oh, yeah. What if, I'm referring to a problem like number 3. When we did this, where is it? It is it. Where is it? My goodness. Oh, there it is. I have papers everywhere. This one. When I did this one, this was a discrete, whether you had to do certain months or books or things that you couldn't break up. But I wanted to talk about what happens if this was one like with time or distance or things that can. You could have 1.5 miles or you could have 1.5 hours, things like that. And they didn't tell you how to do month to month. What would something like that look like? So I'm going to leave that there because I kind of want to use that. let's just make one up. Let's just say that f of x is 5x. I'll put mine on the screen. 5x. And x is the number of miles. And f of x is the distance you run. That doesn't make sense. That is a bad, bad example. Let me see. Okay, all right. A jogger runs 5 miles for every hour. What's the final distance? That makes more sense. Okay, I got my head wrapped around this. So let's say x represents the number of hours they're running, and they're running at 5 miles for every hour. So what is the total distance they're running? So that can be partial. So when you make your graph, they could run 0 and 0, right? But what happens if they run one hour? Gonna have 5, right? What if they run 2 hours? How far have they gone? 10. So it's way up there. So my point is, it's not a discrete graph anymore. We have a continuous graph. So for one, you wouldn't go through here because we're not going to go into negatives, but it would be continuous. But now if I asked you for the range and domain, let's see, I always like to put domain first because that's my x and then that's my y. We're not talking about individuals like here, where you have to list them separately. That's for a discrete graph. For a continuous graph, we're going to use inequalities. So the domain for something like this would be x is what? Actually, x could be anything over here, couldn't it? I mean, really, he could go for 50 hours if he wanted, and then he's going to have a lot bigger distance. I mean, I don't know if he could actually do that, but that is how I would write my domain. It could be x is greater than or equal to 0. It just can't go negative. And then what about the range, the distance in miles? Again, it could be anything as long as it's bigger than 0. But we don't want to have specific values listed. So this could be an answer. So you need to understand that it could look like this for domain and range, or it could look like this, depending on if you have a discrete graph or continuous graph. Do you have a graph where they specifically said you can only do it in certain increments? Or do you have a graph where it could be anything in between? All these points could be a possibility. All right, I think that's all we got today, folks. Take care. We'll see you soon.